So we know that a cone is dependent on R and H. And see this hypotenuse length? We call that L, or S for slant height, okay, or L for just the length of the side here. The surface area is the following. First the bottom, pi r squared, and then it's pi r L. So we don't need to prove this part, pi r squared. Okay, we can easily do that by just doing this and find the area under the curve and timesing it by 4. Okay, so the challenging part for us will be this one. How do you find that around, right? This around surface area is pi times r times L, where L, of course, is this, right? R squared plus H squared. So we'll think about how we could generate such a volume. Okay, we're going to use a coordinate system. And we can generate a cone by spinning a line about the x-axis. Can we not?
Yeah.
Okay. And we still have to match this exact dimension. Okay, so if that right there is equal to r, and from here to here is h, and you spin that around, okay, you get the cone. Now what's the equation of this line then? Y is equal to?
R over hx.
That's right, r over h. That's the slope, right? R over h x. Okay, so now we're ready to go. The surface area will be integration from 0 to h, right? 0 to h here, 2 pi y, right? Times by 1 plus y prime squared dx. This is the formula. We of course need to change all the y's into x. Okay. So y is equal to r over h x. If you differentiate that, you get just r over h. So you get 1 plus r over h squared, which is a constant. The whole thing is a constant, right? So we have 2 pi. So I'm going to take out all the constants. 2 pi r over h plus this root. 1 plus r squared over h squared. And we only have integral from 0 to h for x. Okay, so 2 pi r over h squared plus r squared, and that's going to be x squared over 2. Got to plug in h and then 0. So we have 2 pi h squared over 2 minus 0. Oh, sorry, I made a mistake here. It should be h squared. Good. Because now we have h here, another h here. It will cancel out with that h squared, right? This 2 will cancel out with this half. So we have pi r h squared plus r squared, which is L, right? Pi r L. So we proved it. So we've just shown that the side is pi r L. And this is easy. So therefore the surface area is pi r squared plus pi r L.